Hello everyone. In today's video, we will look at solving lead code problem number 528, random pick weight. Let's go over the question. You are given a zero indexed array of positive integers w where wi describes the weight of the ith index. You need to implement the function pickIndex which randomly picks an index in the inclusive range 0, w.length minus 1. The probability of picking an index I is wi divided by sum of w. For example, if w equal to 1, 3, the probability of picking index 0 is 25% and the probability of picking index 1 is 75%. This is shown in the example 2 where w is equals to 1, 3 and the expected output 1 appears 4 out of 5 times because it has 75% probability of getting picked, and 0 appears only one time because it has 25% probability of getting picked. From LeetCode question description and example test case, some folks watching this video still might have questions on what is required to be done. So let's spend more time on understanding the question. The ask is simple. When pickIndex is called, we have to return an index. The index that we pick to return should be based on the weight. From this W array, we can easily compute this probability array. This probability array represents the probability of the index getting picked. Probability of index 0 getting picked is 1 by 8. Similarly, for index 1, probability is 5 by 8, and for 2, probability is 2 by 8. Number 8 is sum of all the elements in array W, that is 1 plus 5 plus 2, which is 8. We can convert this probability array into decimal number representation, and this is how it would look like. This array says index 0 has 12.5% chance of getting picked. Index 1 has 62.5% chance of getting picked. Index 2 has 25% chance of getting picked. Once we have the probability array, it will be easy to understand what the question is asking for. If we call pickIndex function 8 times, then this will be the answer. Let's see how. 1 out of 8 pickIndex call returns 0 because index 0 has weight 1. 5 out of 8 pickIndex call returned 1 because index 1 has weight 5. 2 out of 8 pickIndex call return 2 because index 2 has weight 2. And this is not the only answer. There can be multiple answers. This is also a valid answer. 1 out of 8 pickIndex call return 0 because index 0 has weight 1. 5 out of 8 pickIndex call return 1 because index 1 has weight 5. 2 out of 8 pickIndex call return 2 because index 2 has weight 2. Now that we understand what the question asks for, let's think about a solution. Idea is to convert the probability array into an array representing range of numbers, then generate a random number from uniform distribution, find out which range the random number generated falls into and return its index. Let's visualize the working of the solution. We will calculate the range based on cumulative sum or prefix sum, and at later point we'll see why this works. Cumulative sum of probability array till index 0 is 0.125, and we will append this in the prefix array. Similarly, cumulative sum till index 1 will be appended to prefix array, which will be 0.125 plus 0.625. So the number appended to prefix array will be 0.75. Similarly, we will append cumulative sum of probability array till index 3 in prefix array. And finally, we will get this prefix array where first element 0.125 represents range of numbers from 0 to 0.125. Second element 0.75 represents range of numbers from 0.126 to 0.75. Third element 1 represents range of numbers from 0.76 to 1. Next, we will generate a random number with uniform distribution between 0 to 1 and assign it to target variable. Let's say randomly generated number is 0.2, which is assigned to the target. Now we have to check which range of number does this target number fall into and return its index. We will start by looking at the first element of prefix array, and check this condition to determine if target is falling in this range of numbers. No, it's not. We'll increment our ith pointer to second element and check this condition to determine if the target is falling in this range of numbers. 0.2 does fall into range 0.126 to 0.75, hence we'll return 1. Let's understand why does the prefix sum defining range-based solution works. We can convert array w to w dash dash where we add the occurrence of the index based on its weight. We can generate a random number that will represent the index selected in w dash dash array. This random number will be generated by uniform distribution with range of indices of w dash dash array, which is 0 to 7. Now we can say that probability of picking value 0 by randomly generated index number is 1 by 8. Similarly, probability of picking value 1 is 5 by 8 and probability of picking value 2 is 2 by 8. We get the same probability array that we saw earlier when discussing the prefix sum solution to define the range of numbers. Now that we know prefix sum always works, let's look at a simplified solution to the problem which is based on previous prefix sum solution. We will call this scaled up prefix sum. We will convert the W array to this new prefix array, which is 168. This new prefix array is a scaled up version of previous prefix array. Previous prefix array is a scaled down version where number values will range from 0 to 1. In scale up prefix array, the number values will range from 0 to sum of all the weights. Now we have prefix array, everything else remains the same at a scaled up version. We will compute target by generating a random number from uniform distribution and then we will multiply it by prefix minus 1. This is to scale up the target to take values from 0 to 8. Let's say target is 6.4. Let's see which range does the target fall into by checking this condition. Let's start by first element. The answer is no. Let's increment the ith pointer to the second element. Let's check again if the target falls into this range. No, it does not. Let's increment the pointer. Let's see if the target falls into this range. Yes, it does. Hence we return the index 2. Let's look at the code. In the init function, we create the prefix array using cumulative sum of the weights. And then at line 12 in pickIndex function, we use random.random to generate a random number between 0 to 1 with uniform distribution. And then at line 13 to line 15, we have a for loop to check which range does the target fall into and return its index. Let's do a complexity analysis of our code. The total time and space of init function is O of n. The total time of pickIndex function is O of n and the total space is O of 1. Let's discuss on optimizing pickIndex function. We know the prefix array because being cumulative sum will always be sorted. And we want to find which range does the target number belong to in the prefix array. Based on the info that array is sorted and we have to find the range of the target, we can use binary search to optimize pickIndex. Let's see the code of binary search optimized pickIndex function. In pickIndex, we use binary search algorithm to determine which range does target belong to and return its index. This is similar to LeetCode problem 35 where we find index in sorted array to insert the target to keep the array sorted. The total time and the total space of init function remains the same, which is O of n. However, for pickIndex, the total time reduces from O of n to log n because of binary search, and the total space complexity remains the same, which is O of 1. Thank you for watching this video and stay tuned.